If A is any square matrix, then lambda is a constant. Determinant of A minus lambda is equal to 0 is called the characteristics equation. The characteristics roots are lambda is equal to 5 plus root 33 by 2 or lambda is equal to 5 minus root 33 by 2 are the characteristics equation. Minus into plus, it is minus 4 times lambda multiplied by minus sign, minus 2 lambda, minus into minus plus 2 is equal to 0. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session I am going to discuss regarding very important unit, that is unit number 3. In unit 3 you are going to study regarding matrices. One part is matrices and second part is the derivatives, that is differentiation. In first part in matrices we are going to study regarding finding the rank of a matrix and Cayley-Hamilton theorem. So that is the characteristics roots of a square matrix. Characteristics roots are also called as the eigenvalues, finding the eigenvalues. And in the second part of the unit we are going to study regarding differentiations and application of differentiation. That's it. Now let us move on to the first part. In the first part we are going to study the first concept as the characteristics equation, or they are also called as the characteristics roots, or it is also called as the eigenvalues. Characteristics equation and roots of a square matrix. The characteristics roots, or it is also called as the eigenvalues of a square matrix. So suppose if A is any square matrix, if A is a square matrix and I is an identity matrix of same order of A, then determinant A minus lambda I, determinant of A minus lambda is equal to 0, where lambda is a constant, is called the characteristics equation of A. If A is any square matrix, then lambda is a constant, determinant of A minus lambda is equal to 0 is called the characteristics equation of A, and the roots of this equation A minus lambda is equal to 0 are called as the characteristics roots, or they are also called as the eigenvalues, or they are also called as the latent roots of the square matrix. The characteristics roots, they are also called as the eigenvalues of a square matrix. So that means if A is any square matrix, then lambda is a constant, determinant of A minus lambda is equal to 0 is called the characteristics equation, and the roots of this characteristics equation are called as the characteristics roots, or they are also called as the eigenvalues. Now let us come to an example. Let us move on to a problem. So that is, let us consider a matrix A is equal to 2 minus 1 0 1. Find the characteristics roots of the equation A. Now the characteristics equation, let us write the characteristics equation of A is A minus lambda I, A minus lambda I. So what is A minus lambda I? A minus lambda I is equal to matrix A 2 minus 1 0 1 minus lambda into identity matrix is 1 0 0 1. This can be written as 2 minus 1 0 1 multiplied by lambda, lambda 0 0 lambda. Subtract this. 2 minus lambda, again minus 1 minus 0 is minus 1, again 0 minus 0 is 0, and 1 minus lambda, 1 minus lambda. This is the characteristics equation. Then to find the characteristics equation, now the characteristics equation is determinant A minus lambda I is equal to 0. Determinant of A minus lambda is, that is determinant 2 minus lambda 1 minus 1, then 0, and 1 minus lambda is equal to 0. Simplify this matrix of order 2 rows 2 columns. Just find out the determinant of this. So 2 minus lambda into 1 minus lambda, minus into minus plus, 0 into 1 is 0. Simplify this, that is 2 minus lambda into 1 minus lambda is equal to 0. 2 is equal to lambda, or 1 is equal to lambda. So therefore lambda is equal to 1 or lambda is equal to 2 are called the characteristics roots. Therefore, the characteristics roots are they are also called as the eigenvalues. Eigenvalues are 1 and 2. 1 and 2 are the eigenvalues. So, lambda is equal to 1 and lambda is equal to 2 are the eigenvalues for the given square matrix. Hope you follow. Now, let us move on to a similar type problem. So, now example number 2, if A is equal to 1, 2, 2, 1, find the characteristics roots of A. Now, just write down the characteristics equation of this. Now, the characteristics equation of A is A minus lambda I. So, that is, what is A? A is equal to 1, 2, 2, 1 minus lambda into 1, 0, 0, 1. This is equal to 1, 2, 2, 1 multiply by lambda, lambda, 0, 0, lambda. Subtract this, 1 minus lambda, again 2 minus 0 is 2, again 2 minus 0 is 2, again 1 minus lambda. Now, the characteristics equation of this is now A minus lambda is equal to 0. The characteristics equation determinant of A minus lambda is equal to 0, that is determinant 1 minus lambda 2, again 2, 1 minus lambda is equal to 0, cross multiplied, 1 minus lambda into 1 minus lambda, minus 2 2s are 4. Now, simplify this, 1 minus lambda into 1 minus lambda is 1 minus lambda the whole square minus 4 is equal to 0. Now, this is of the form A minus B whole square, A square plus B square minus 2AB, 2 into lambda into 1 is 2 lambda, minus 4 is equal to 0. Put it in order, lambda square minus 2 lambda minus 4 plus 1 is minus 3 is equal to 0, a quadratic equation. Solve this quadratic equation. Now, that is lambda square minus 2 lambda minus 3 is equal to 0. Factorize this by using cross multiplication. Lambda into lambda, lambda square, 3 into 1 is 3. Now, let us represent this as minus and plus. Minus 3 into 1 is minus 1, minus into plus it is minus 3, plus 1 is minus 1, minus 3 plus 1 is minus 2. So, we can write lambda minus 3 into lambda plus 1 is equal to 0, lambda minus 3 is equal to 0 or lambda plus 1 is equal to 0, lambda is equal to 3 or lambda is equal to minus 1. So, therefore, lambda is equal to plus 3 and lambda is equal to minus 1 are the characteristics roots, or they are also called as eigenvalues. Characteristics roots are eigenvalues for the given matrix. Hope you followed, right? Now, let us move on to the third problem. If A is equal to 1, 2, 3, 4, find the characteristics roots of A. That is nothing but eigenvalues. Same. The characteristics equation of A is A minus lambda I. That's equal to, what is A matrix? 1, 2, 3, 4 minus lambda into 1, 0, 0, 1. So, this is equal to 1, 2, 3, 4 multiply by negative sign lambda 0, 0, lambda. That's equal to 1 minus lambda, again 2 minus 0 is 2, again 3 minus 0 is 3, 4 minus lambda. So, this is the characteristics equation. Now, the characteristics equation can also be written as, now A minus lambda is equal to 0 implies determinant of this, determinant 1 minus lambda, 2, 3 and 4 minus lambda is equal to 0. Simplify this, 1 minus lambda into 4 minus lambda minus 3 2s are 6 is equal to 0, 1 into 4 is 4 minus lambda minus 4 lambda minus into minus plus lambda square minus 6 is equal to 0. Put it in order, lambda square minus 5 lambda, 4 minus 6 is minus 2 is equal to 0, a quadratic equation. So, you cannot factorize this. So, this can be solved by the method of Sridharacharyya's method, that is, here What is A? A is equal to 1, B is equal to minus 5, C is equal to minus 2. So we can write lambda is equal to minus B plus or minus root of B square minus 4AC divided by 2A. Here lambda is equal to minus into minus plus 5 plus or minus root of B square. 5 square is 25 minus 4 into A is 1, C is minus 2 divided by 2 into A is 1. So this is lambda is equal to 5 plus or minus root of 25 minus into minus plus 4 2s are 8 divided by 2. Lambda is equal to 5 plus or minus 25 plus 8 is 33 divided by 2. So therefore the characteristics roots are lambda is equal to 5 plus root 33 by 2 or lambda is equal to 5 minus root 33 by 2 are the characteristics equation. Characteristics roots are the characteristics roots. Therefore the characteristics roots are 5 plus root 33 by 2, 5 minus root 33 by 2. So the characteristics equation of the given matrix A is equal to A minus lambda is equal to 0. That is, we will get 1 minus lambda, 2, 3, 4 minus lambda is equal to 0. Cross multiply 1 minus lambda into 4 minus lambda minus 6. So 1 into 4 is 4, 1 into lambda is lambda, minus 4 lambda, minus into minus plus lambda square minus 6. Lambda square minus 4 minus 1 is minus 5 lambda, 4 minus 6 is minus 2. Now this can be solved by the method of the formula x is equal to minus b plus or minus root of b square minus 4ac divided by 2a. That's it. Move on to the next problem, fourth problem. If a is equal to 1, 3, 2, minus 4, find the characteristics roots, or they are also called as the eigenvalues. Eigenvalues. Now, just same as usual, the characteristics equation of A is A minus lambda I. That's A. What is A? 1, 3, 2, minus 4 minus lambda into 1, 0, 0, 1. That's equal to 1, 3, 2, minus 4 minus lambda 0, 0, lambda. Simplify this. 1 minus lambda, 3 minus 0 is 3. Again, 2 minus lambda is 2, minus 4 minus lambda. Now the characteristics equation, is A minus lambda is equal to 0. That is determinant 1 minus lambda 3 and 2 times minus 4 minus lambda is equal to 0. Simplify this. 1 minus lambda into minus 4 minus lambda minus 6 is equal to 0. 1 into 4 is 4, 1 into lambda is lambda, minus into minus plus 4 lambda, minus into minus plus 4 lambda square minus 6 is equal to 0. So put it in order. Lambda square, 4 lambda minus lambda is plus 3 lambda, minus 6 minus 4 is minus 10 is equal to 0. So here we can factorize this. Lambda square plus 3 lambda minus 10 is equal to 0. Factorize this. This can minus 5 2s are 10, and this is plus 5 and minus, plus into minus minus. So you can straight away write lambda plus 5 into lambda minus 2 is equal to 0. Lambda plus 5 is equal to 0. Lambda minus 2 is equal to 0. Lambda is equal to minus 5, or lambda value is equal to plus 2. So therefore the eigenvalues are lambda is equal to 2 and lambda is equal to minus 5. That's it. Minus 5 and 2 are the eigenvalues for this matrix, right? Now move on to the next problem. Let us consider 3 rows 3 column. This is very important. Let us consider 3 rows 3 column matrix. Find the characteristics roots of a square matrix A is equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3. This is an important problem for 5 or 7 marks. Now as usual, the characteristics equation is the characteristics equation of A is A minus lambda I. That is, what is A matrix? 1, 0, minus 1, 1, 2, 1, 2, 2, 3, minus lambda into identity 1 0 0 0 1 0 0 0 1. So this can be written as 1 0 minus 1 1 2 1 2 2 3 multiply by lambda. Lambda into 1 is lambda 0 0 0 lambda 0 0 0 lambda. Simplify this. This is equal to 1 minus lambda, remaining is 0 minus 1 as it is. 1 minus 0 is 1, again 2 minus lambda and plus 1, again 2 minus 0 is 2 and 2, then 3 minus lambda. Now the characteristics equation is determinant of A minus lambda I is equal to 0. That is determinant of this matrix 1 minus lambda 1 2, then 0 2 minus lambda 0 2 minus lambda 2, then minus 1 1 and 3 minus lambda is equal to 0. Simplify this third order determinant, you will get a cubic equation. Solve that cubic equation, will give the values of lambda, they are nothing but the eigen values. Now simplify this, expand with respect to first row. This is plus, minus and plus. 1 minus lambda into, this is gone. What we will get? 2 minus lambda into 3 minus lambda minus 2. Minus 0 into the number is 0. Minus 1 into, this is gone. 1 into 2 is 2 minus 2 into 2 minus lambda is equal to 0. Now this is 1 minus lambda into, simplify this, 2 3s are 6, minus 2 lambda, minus 3 lambda, minus into minus plus lambda square minus 2, minus 1 into, multiply by 2, 2 2s are 4, minus into minus plus 2 lambda is equal to 0. So this is 1 minus lambda into, put it in order, lambda square, minus 2 minus 3 is minus 5 lambda, 6 minus 2 is plus 4, minus 1 into, this is 2 minus 4, that is 2 lambda, 2 minus 4 is minus 2 is equal to 0. Now simplify this again, multiply by 1, 1 into lambda square is lambda square minus 5 lambda plus 4. Now multiply by minus lambda square into lambda is lambda cube, minus into minus plus 5 times lambda square, minus into plus it is minus 4 times lambda, multiply by minus sign, minus 2 lambda, minus into minus plus 2 is equal to 0. Now this can be written as minus lambda cube, then lambda square terms 5 plus 1 is 6 times lambda square, and lambda terms minus 5 minus 4 minus 2. So minus 5 minus 4 is minus 9, minus 9 minus 10 minus 11 lambda, and the constant, what are the constant terms we have? 4 plus 2, 4 plus 2 is 6 is equal to 0. Now multiply by negative sign, multiply by minus negative sign, what you will get? Lambda cube minus 6 lambda square, minus into minus plus 11 lambda minus 6 is equal to 0. This is the characteristics equation. Now solve this cubic equation, you will get the eigen values. Now how to solve this? Now to solve this, just by error and trial method, find out the value of lambda, put lambda is equal to 1. So if you put lambda is equal to 1, 1 cube minus 6 into 1 square plus 11 into 1 minus 6, that is 1 cube is 1 minus 6 plus 11 minus 6. 11 plus 1 is 12 minus 12 is equal to 0. So 12 minus, so that means what you say, therefore lambda is equal to 1 is a root. Is a root means one value, one eigen value. So lambda is equal to 1 is one eigen value. Now this second one can be simplified by the method of synthetic division. So second one can be simplified by the method of synthetic division. Now I will go to the next page. Now from this, lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0, right? Now, already we got, so lambda is equal to 1 is a root. Now, using synthetic division, just write down the coefficients of lambda cube, lambda square, lambda and constant on the first line. 1, minus 6, 11 and minus 6. Below this write 0. What is the value of lambda? Lambda is 1 is a root. Add this. 1 plus 0 is 1. 1 into 1 is 1. Add this. Minus 6 plus 1 is minus 5. Again multiply it. 1 into minus 5 is minus 5. 11 minus 5 is 6. Again multiply. 6 into 1 is 6. Minus 6 plus 6 gets cancelled 0. If lambda is equal to 1, definitely you will get the last value as 0. So therefore, the reduced equation or depressed equation, is lambda square minus 5 lambda plus 6 is equal to 0. A quadratic equation. Solve this. This can be solved using 2 into 3 lambda into lambda. This is minus and minus. Minus into minus plus. Minus 2 minus 3 is minus 5 lambda. This is my 2 lambda minus 2 into lambda minus 3 is equal to 0. Lambda minus 2 is equal to 0. Lambda minus 3 is equal to 0. Lambda is equal to 2 or lambda is equal to 3. So therefore, lambda is equal to 1, lambda is equal to 2 and lambda is equal to 3 are the eigenvalues. These are the eigenvalues in case of a third order determinant. That's it. Hope you followed. So very simple and very important for 7 marks. So you may expect this type of questions for 7 marks. So if you get a third order equation, just find out a root. So lambda is equal to 1 is a root. Then using synthetic division, write down the coefficient of lambda cube, lambda square, lambda and the constant. Below the first, write down 0, add this, 1 plus 0 is 1, multiply with this lambda value. 1 into lambda is lambda, minus 6 plus 1 is minus 5, again minus 1 into 1 is minus 5, 11 minus 5 is 6, 6 into 1 is 6, minus 6 plus 6 gets cancelled 0. So therefore, the depressed or reduced equation is lambda square minus 5 lambda plus 6. Simplify this, factorize this, you will get lambda is equal to 2 and lambda is equal to 3. So therefore, the eigenvalues or characteristics roots of this equation is 1, 2 and 3. This is how we are going to solve these type of problems. Very important for the point of examination. Hope you followed. Right. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.